And yeah, welcome to next session. I'm happy to have Enrico with us today, who's going to be presenting proof of solvency. Welcome, Enrico.
Okay, cool. I can start. So first of all, let me try to share my screen. Okay, I hope you can see this, right?
Yes.
Okay, perfect. So yeah, like the session of today is dedicated to proof of solvency. So we are not gonna go through Summa specifically, which is the subject of the next session. But of course, I'm gonna make some reference to Summa. And also something else, I think it will be very helpful if this becomes a interactive presentation. So I know that like everyone says that they want the presentation to be interactive, but I actually do want this. And I think that in a later part, there's going to be a part dedicated to the attacks on proof of solvency. And there I'm going to ask your opinion, but also throughout the rest of the presentation, I really encourage you to stop and ask question. Just take the mic and ask question. So the team of Summa is composed by 3 people: me, Jean, and Alex. I believe, I'm not sure that Jean is here in the meeting. Alex is not, but yeah, we are basically working for Summa. Summa is a team inside PSC, which is inside of the Ethereum Foundation, and we are all developers, all engineers. So you will find Jin doing some other session. Alex is gonna do some other session as well. I think the main, you're gonna basically take me as a reference to this V1. So the thing that you're gonna audit for the first, I guess, 7 or 8 weeks, why Academy guys will know better, would be called V1. And later we're going to move to V2, which is slightly different design of proof of solvency. And there, Alex is going to be your reference point and is going to deliver most of the content related to that. Also, we are kind of engineers, so we are not by background cryptographer or mathematician. And I think you will be able to tell according to how we explain stuff that we are not mathematicians. So we are gonna have a more, let's say, engineering-based way of explaining things. Even, for example, when we're gonna speak about circuits or ELO2, you will see that we are gonna be more focused on like the API itself, like the actual usage of ELO2, and we're gonna touch math more on V2 because this is more related to techniques that go beyond ELO2. But I think that for V1, yeah, we're not gonna touch more deeply like the, let's say, the prover part. We are gonna just take like the minimum requirement for that. Okay, so let's go into the topic. Proof of solvency is a proof that a custodian is solvent at a specific moment in time. So the solvent means that their assets are greater than the liabilities. And we're going to see that what that means in a moment. But also, I think an important concept here is the specific moment in time. So this is a snapshot in time and doesn't say anything more about the solvency before and after this moment in time. So who is a custodian? A custodian is, for example, so like most of the time you see this proof of solvency concept applied to exchanges. So there are like many exchanges like Binance, Kraken, BitMEX, that they are actually already implementing a proof of solvency solution. But in theory, proof of solvency can also apply to wallets, like custodian wallets, because they are basically doing the same thing as an exchange is doing. So they are like managing the private key of a user on their behalf. So there's like some trust between like the user and the custodian. So this is just for your information that proof of solvency doesn't only apply to exchanges. Also, another note on like the terminology, when you hear proof of reserves, most of the time means the same as proof of solvency. We decided to go for proof of solvency mostly because we like the idea was born from a Vitalik's blog post that I encourage you to go and read. And in that blog post, it says proof of solvency. So we decided to go for proof of solvency. Also, proof of reserves might be a bit confusing because, at least in my mind, reserves kind of indicates like what you can, something that you custody. So, like originally, I thought that proof of reserves only referred to proof of assets. So this is just to say, to make some clarity on the terminology. So proof of reserves equals proof of solvency. What are like the assets? The assets, as you know, like these are like the cryptocurrencies that the exchange or the custodian is controlling, and these live on chain. So everyone can kind of monitor these assets, can check from a chain like a Etherscan or another block explorer to see how many assets are controlled by an address that is publicly known to be owned by a custodian. And an important thing that we notice speaking with exchanges mainly is that they actually don't control the private keys associated with this address because it might be too risky, or just for like security practices, they outsource this service to a third party. So this is more like a practical issue. Like when we say that, okay, like for a user for any private user to prove that they control a wallet is rather simple. They can just open MetaMask and sign a message or perform a transaction, and then they can tell everyone, yeah, this is my address. But actually, for an exchange, it's not that easy because of this issue, and because all of the practices that they have to store and manage these keys. So yeah, like the assumption made on the usage of these keys are different when you are working with a custodian. And of course, these assets should map one-to-one the deposit of the user. So this is basically the definition of solvency. It can be like the ratio can also be in favor of assets, but it should never be that the assets are less than the deposit of the user. And when we say deposit of the user, we also mean liabilities. So this is like a screenshot. So if you go to your exchange account, if you have one, like your balance is basically, from the point of view of the exchange, is a liability. And when we say liabilities, we mean like the aggregated user balances. So all the balances for all the users are kind of, they form the liabilities. And what is the difference here? Like this last point is the, let's say, the core thing. Like the accounting of these liabilities, of the balances of the user, is happening inside the custodian database. So this is not public, of course, and this is like the fact that this is performed privately. It is what makes centralized exchange like fast and cheap, but the trade-off is that you cannot really attest to these liabilities. Like if you ask someone from the outside, they cannot say what are like the aggregated liabilities of Coinbase, because this is all happening inside their database. And this is the reason why we need proof of solvency. If everything was public, which is basically what happens in a decentralized exchange, we don't need proof of solvency. So this is just an example of like the balance sheet of an exchange, of a custodian. Let's say that Bitcoin is worth $20,000 and FTT is worth $1. So if this is the balance sheet of the exchange, do you guys think this is solvent or not?
No, because there's not a 1-to-1 ratio.
Yes, exactly. That's correct. So that's the point. Like I think this is not like a general agreement on what solvency means. So there might be like someone that says that this is solvent, because if you convert everything to dollar, this is actually solvent. So if you convert the assets to dollar and the liabilities to dollar, the ratio is 1-to-1. But this is not at least Summa means as solvency. So for our understanding, this is solvency. Like when the assets for each currency, the mapping is 1-to-1, because like from this situation, like the price can fluctuate, and the day later maybe they are no longer solvent, even when everything is denominated to dollars. Also, this is like another graph. This is nothing particularly complex, but it's just to underline again the concept of the snapshot in time. So you can be solvent at T0 because this is like a balance sheet that means solvency, but the moment later, if you do some trades as an exchanger, you're no longer solvent. So you always have to think that this is a snapshot in time. And this is more like I don't know, like a business thing probably, but the goal of Summa is to allow custodian to do this proof of solvency very frequently, so that you can I don't know, assess the solvency of a custodian every half an hour, every hour. So that's where most of our engineering effort goes. Because if you see like, for example, Binance, they also have a nice blog post where they are explaining their solution. But their solution is basically takes like days. Like every proof of solvency takes like 2 days to build. And even if like 2 days is way better than I don't know, 1 year, that is probably be the case when you rely on traditional ways of doing proof of solvency. I think that 2 days is still not good. So we are trying to. I think right now you can do this almost on an hourly basis according to the power of the machine and the money that you want to put and the number of, let's say, the parallelization that you want to perform. But like in general, a very important focus for us is to make this process very frequent, that you can run a round. So this is a term that we're going to use very often, like round, when we describe a full proof of solvency flow. So we want to make a round, we want to make possible to do this round very frequently and at a low cost. Is there any question up to now? I see that there's also chat. Okay.
Yeah, I see Paniker has a hand
Hey,
raised.
so I had a question. So I guess I was reading in the docs that you're doing this one-to-one solvency method because of price fluctuations, which makes a lot of sense because obviously crypto prices can change a lot, and a system that is solvent now can become insolvent later. But if the difference between the assets and the total liabilities, like as the difference grows, then the risk of price fluctuations also decreases, right? So if let's say you had one Bitcoin in assets and 1.5 in liabilities, but you also had let's say 30 or 40,000 FTT tokens, then the risk that it will become insolvent is very less, right? So why? So like, I guess doesn't this protocol like limits the ability of an exchange to handle their funds and maybe move it around and stuff like that?
Yes, that's a great point. So, first, yeah, like that's correct. This is something that a feedback that we had from Coinbase, for example. Like what they do, for example, like now Coinbase, they don't have a proof of solvency protocol, like a cryptographic based proof of solvency protocol in place, but they just do it like with regular auditors. And what they do is basically they, when it comes the moment to do the proof of solvency, they kind of rebalance all their assets in order to be solvent in this paradigm of one-to-one mapping. So they probably, between like two proof of solvencies, they don't have like this one-to-one mapping, but they kind of rebalance their assets according to, I don't know, some particular politics that they have. So just to answer your question, yeah, I think this is probably limiting for like the exchange point of view. And I would say that nothing according to our protocol blocks an exchange to not do that. So you will see this better tomorrow in a, well, not tomorrow, in the next session related to Summa, but potentially an exchange can now do the thing that you said. So they could potentially have more FTT, and I don't know, they can have like much more FTT, and that they can, and this the core there is that since everything is public, since everything is like committed to a public place, people from outside are able to judge. So in that case, it will be like the user that is able to tell if this is good enough for them. So let's say if they have like in this case, like if they have like 1 billion of FTT, the conversion in dollar would be like much more favorable of in on the asset side. So in that case, yeah, it would be like the user judging if they can trust or not the exchange.
Yeah, there's also a
Okay,
question from Varun. I see your hand raised.
TradFi solvency in case some people. Okay, I think this is more like not a question. Shouldn't proof of solvency be satisfied at any time to be safe rather than at a single snapshot in time? Yeah, of course. Like this is like the what we aim for. I mean, any time is really impossible. Like you need to define like some latency. It can be like any second or any minute. I don't know. Any time is impossible. But like we want to make this possible. Like I don't know. Probably we can aim to like a minute per minute basis proof of solvency. But yeah, of course, this will be very cool. I think this will be expensive for proof construction. Yes, I mean this is a very interesting point. Like that's why Binance proof of solvency takes 2 days, because in their design, the proof is generated before the liabilities commitment. While in our case, the proof is generated later. So you can do the commitment and then take your time to generate the proofs. But the importance for the frequency is the commitment. So maybe Carly, you will see an answer tomorrow, well, next session, and remember this question, because this will be very important to understand why our design allows to this frequency. Thus means that each user of the custodian is also solvent. Okay, I think this, Dennis, correct me if I'm wrong, this probably has to do with like margin trading or like this stuff where like the user might be in debt with the exchange. Is it the case?
Yes, because so by definition you showed, it's not obvious that if custodian is solvent, then all users of this custodian also solvent, right?
Yes.
Maybe the case that custodian is solvent, but there is a user that is not solvent.
Yes. Okay, that's a very good point. So as you like, the Binance solution is actually accounting for that. So Binance is accounting for the possibility that a user is in debt, but our solution does not. So in our hypothesis, the exchange, well, the user is always solvent, and I think that for most of the crypto exchanges, this is good because they don't have this margin trading feature. But of course, this is something that we already have in mind, and we have some ideas on how to implement that if it becomes needed. If the ratio of assets and liabilities is made public and there's some over collateralization, maybe something similar to what is suggested to build. I think I probably
That was the first question, like voice question from.
Yeah, exactly. Well, but I think this is another point. Like in theory, this whole design. So we say that for crypto exchanges, the ratio is 1-to-1. So that's how it should be used by exchanges, by crypto exchanges. But you can easily port this concept also to banks. So in that case, they have different ratio. Probably it's like, I don't know, 1/4 or like 25%. They must have assets covering 25% of the deposit. So you can actually apply this to other dynamics, and you can the user of this protocol, the user meaning like the custodian, can actually choose the ratio as they want based on their obligations. If the protocol is not balancing the asset regularly, then how are you going to achieve the goal of generating these proofs? Doesn't regular balancing disrupt the normal functioning of the exchange? Yeah, I mean, these are like more discussion that are more related to us dealing with the customers. And yeah, probably, but as we said previously, we don't really like, okay, this is something that I didn't mention, but in general, the 99% of the code and what Summa is building is on this. Now we're going to go through that, but it's going to be focused on the proof of liabilities. So like on the proof of assets, we don't really enforce rules. So if an exchange, as I think was, I think, I don't remember who asked the question. Maybe it was 0x Panic Error. Like if they want to, I don't know, have like only FTT as assets, then it's okay. Let's do this. If it's up to them, like they're gonna make this public, and then user are gonna judge if their solvency is met or not. So we are not really constraining the exchange or like the custodian to to have this one-to-one balance. But according to us, this is the definition of solvency. Yes, good answer also, Sebastian. Okay, that's very good that you're asking many questions. He was mentioning that exchanges use third-party service to manage their keys. Does this mean that the exchange will have to share their private keys with the third party? Yes. I mean, probably they don't. It's not that they share their private key with their third party. They actually never see this, and it's the third party itself that is creating this key, and they are storing it. So there's like I think there's a service called Block Road. I don't remember the name, but they are like companies that they do this. So I mean, it sounds bad, but yeah, there are business that are their role is to store keys on behalf of someone else. So in theory, when you're like using an exchange, you're not even trusting the exchange. You're trusting this third party, which is fun. Does the term asset in the proof of solvency refers only to on-chain assets? Okay. Yes, it refers only to on-chain assets. This is a good question that I think there are many people that are asking because, I don't know, maybe the exchange has like a lot of properties or, I don't know, a lot of real estate business that they are in debt with. So that wouldn't make them solvent according to the definition of solvency. Let's say the standard and academic definition of solvency. But in our case, we only consider on-chain assets because the problem is even if we are considering like off-chain assets as dollars, okay, it's very difficult to prove cryptographically that you have some dollars in your bank. So this is a good challenge that you can probably spend some time thinking about it. Like, how can I prove cryptographically that I have $1,000 in my bank? You cannot. Like, you can rely on a bank that can sign this balance, or you can use something like ZK email or like some other attesters, but still, you're still trusting the bank that is telling that you want some dollars. So this is very difficult to deal with, and we only refer to on-chain assets. Similarly, liabilities here mean proof of platform liabilities. Yes, exactly. So when we say assets and liabilities, we only refer to on-chain assets, and as liabilities, user balances. Thus, I think I already answered this question. Okay, am I missing some question, or I answered all of them?
I think all.
Okay, perfect. Okay, very good. I like this type of discussion. So now we are gonna go through a flow of proof of solvency. So this will be before general, and then we're gonna go to a more specific flow. So the flow works like this. The custodian is publishing to, here we say like public bulletin board, because like all the existing solution actually just publish this stuff to their website. So, but in Summa, we publish this stuff to Ethereum, but the importance here is that this is something public, that is something that cannot be modified, and is static, is timestamped. So of course, a website is worse than Ethereum, but for many cases it might be good enough. So they will like publish a proof of assets. They will publish a proof of liabilities. So we're not gonna explain what this means right now. And this two steps, 2 arrows, can actually happen synchronously. So there's no particular reason why one should be before or after than another. And at this point, the world, so like everyone that doesn't need to be a user of the exchange, can verify the solvency of the exchange, of the custodian. So they will take the proof of assets, the proof of liabilities, and check whether it's solvent or not. So why do you think that there's another step here? Like, why can't the word, like, can the process stops here at this point? Like, why we need also this other part? I don't know if someone has any idea. You can either take the mic or answer in the chat. Okay, yes, this is close, Sebastian. This is close to the right answer. But there's also another, like, kind of subtle point, which is like the most important point. To be ensure that the exchange doesn't ignore big user to being solvent, correct? Yeah. So the user deposit adapt to the total. Yeah, I think this all of these three answers are correct in a way, but I'll try to explain this also in my words. So the point is, like, when the custodian generates this proof of liabilities. So I like to say that this proof of liabilities is just an opinion of the custodian, an opinion that is not challenged yet. So at this point, the custodian can say whatever they want about the liabilities. Really, they can say, "Yeah, my liabilities are $1, really," and from the word point of view, like from someone that is not a user of the exchange, they cannot, they simply don't know if this is true or not. So the only way to check that these liabilities are actually accounted for correctly is to pass to each user a proof of inclusion and let them verify if this proof of inclusion is correct. And if this is not, they can challenge the custodian. They can tell the world that they were not included correctly, their balance was not correct. So this is why we need this step as well, because otherwise, at this point, this solvency means it's like, let's say we can say that this is an optimistic proof. So this is a proof of solvency based on what the custodian believes, says, while here this phase is like, let's say, the fraud proof challenge. So, and there's also, I think I lost the chat. Okay. I think there's also another important observation to make here, is that in theory, to make a proof of solvency fully sound, we need 100% of user to perform this verification. If just one user miss this verification, there's still a probability that the exchange is cheating. And there's a very good paper that I can show you later. Well, if you can ping me on the chat, I will share it with you. But this is about, like, the probability that the exchange is cheating according to the number of users that are performing this verification. So I think there are like a few questions that I skipped. Does the requirement of proof of solvency means that the public keys are not actually public? No, like in our implementation, the public keys are public, and I think in all the existing implementation, the public keys are public. And why do we need to prove how much assets we have on chain if that can be looked up by querying for the public keys assets? Yeah, so this is correct, and that's actually what proof of asset means. So we're gonna see this in a second, but what you're gonna do is basically you need to prove, you're not really proving how much asset you have. You're just proving that you control some public key, and everyone can, as you say, look up for the asset. Can you give an example of on-chain liabilities? Yeah, I think, yeah. These answers, Amit and Sebastian, are correct. They're not on-chain liabilities. Okay, so just the last thing that I wanted to mention on this slide is like this function of verifying proof inclusion takes three inputs. So one is the proof of inclusion, one is the proof of liabilities, and one is the user data. And I think right now, in the next slide, I'm gonna give you a clear explanation, I hope, for what this means. So what this is like the one that before was the proof of assets. And as I said before, this is just signing a message. So the way for a custodian to prove that they have some assets is to prove that they control some public key, and they do that by signing a message. So this is like we don't have enforcement to what the message should be in Summa protocol, but you will probably need to sign a message that has something to do with who you are. Like, I don't know, you can say Binance, like if the custodian is Binance, the message should be something like Binance is generating proof of solvency on the 17th of January. Because if you just take some random message, yeah, I can just, I don't know, take any message that I see outside and say, yeah, this is my message. Then I own this this public key, and of course this is not the case. And there's also in the history of proof of solvency, there's also another way of doing this proof of assets. That is basically by announcing a transfer. So I'm Binance, and I say, hey, on like today at midnight, I will transfer all my assets to an address. And in this way, I'm proving that I control this address. But I think this is, yeah, you will tell me better, but I don't like this procedure. I think the signing is better, even if it has some drawbacks that we're gonna speak about later. So the second part is the proof of liabilities, the commitment to the liabilities in the detail, and this is not general. I say this is particular. So in this particular case, the custodian will aggregate the liabilities inside a Merkle sum tree, and will publish like the hash and the root hash and the root balance to the public bulletin board. And maybe now it's the case to go through the Merkle sum tree really fast. Well, not really fast, like we can spend time on this. The Merkle sum tree is basically a Merkle tree with an added property that at every level, you also kind of sum together the child nodes balance, and you end up with a root that has in this in the hash, it contains a commitment to the to all the entries of the tree, similar to a normal Merkle tree, and it also contains the sum of the balances of the tree. So, like basically, what you get outside of this is an hash and a balance for each node. And in the context of proof of solvency, the custodian will basically feed this data structure with the usernames and the balances. So this would be the username, and this would be the balance, username, balance, etc. And you will get this root, which hash and balance root hash and root balance gets committed publicly. Okay, so I will finish that and then take the answer, because I see there are like the question, because there are a lot. And yeah, okay, that is the Merkle sum tree, and this is like very, very important. Like you will have to deal a lot with this. So like what is like the procedure to verify the proof of assets is can be done by everyone. So they will just take the signature, the public key, and verify. And actually, there's also another input missing, that is the message. And they will verify that the signature are correct, are valid. And then to verify the solvency, they will just take the balance of the public key. So as one of you said before, like you can extract the balance from the public keys and you can see the Merkle sum tree root balance. So you can just say like, is one greater than the other, basically? Is assets greater than the liabilities? So this tells the world that the exchange is solvent. But as we said before, this is still, at this point, is still optimistic, because the custodian can potentially cheat on the liabilities. So what the custodian does now is like giving a Merkle proof to a user. So it will be like a different proof for each user, and the user can verify their inclusion in this Merkle sum tree by taking the Merkle proof, the root hash. So they will just, like, the procedure is similar to any Merkle proof. So they will take their data. So let's say their data is Alice with like a balance of 20. Alice will take this data, hash them together, and incrementally hash them with the Merkle proof and see if the resulting root hash is matching this one. And they also should check if the resulting root balance is matching with this one. So this is like a flow that is not exactly the one of Summa. We're gonna see now why, but this is basically what happens for any solution that you see outside. So now I'm gonna see look at the chat. Okay, is this MST for liabilities? Exactly, yes. So this is how you aggregate the liabilities into a data structure. So the user, does the proof of inclusion mean each user would have to participate in the protocol? Is that scalable? So, I mean, this is scalable from let's say a technical point of view. I think yes, because like like this Merkle sum tree is not well, it's like log n, so it's still okay to generate these proofs. It's not like a big deal, even if the exchange is has like a lot of user, but it's probably not scalable from like a social point of view. Like it's very difficult to ask 100% of user to verify the proof. And there's, as I said before, there's like this paper that is tackling this problem. So they're like trying to say, okay, what is like a good enough percentage of users performing this verification to guarantee that the probability that the exchange is cheating gets very low. And I don't remember the numbers, but it's like the finding is that there's a very small percentage of users, like 5 or 10%, is already accounting for, let's say, if the exchange is cheating, there's a big chance that they get caught, even if there's just like a few percentage of users verifying. So that's the main takeaway. Also, for this, I think I suggest you there's a presentation that I did. You're seeing my my YouTube history. Like if you check this presentation that I did in London, I lost Zoom. Oh yeah, of course, because I'm sharing. Okay. If you check this presentation, well, basically this is about this problem, like how it's sustainable, how this is sustainable. How can a user prove that they weren't included in the Merkelson tree? Very, very good question. And we're gonna see this in the attacks right now. Maybe I didn't hear correctly, but balances in the Merkelson tree are public. Isn't that a privacy issue? Okay, of course. So the root, only the root is public, and only actually the root balance is public. So the only thing is public is the aggregated sum of liabilities, and no user data is made available to the public. But now we see that there's still a problem in this design. Are users incentivized to disclose the proof that the custodian is cheating? Okay, so now we are getting more into the, I don't know, psychology or like social point of view of a proof of solvency. But like, let's say you are a user and you receive a proof that the exchange is cheating. What do you do? It depends on how, like, your personality. Like if the first thing that you probably do is like go and withdraw everything from the exchange. And if you are like also a good human being, you can disclose this to the public. But there's no incentive in the design for user disclosing the proof. And there's also another point where like incentive might take place, that as the question from Sebastian was, like you can probably think that the custodian might incentivize user to verify their proof. So I think, I don't remember which exchange, but they do a sort of a lottery. So I don't know, let's say based on every user that performed the verification, you can win some money, like something, you get an incentive for doing that. We can have a situation where the exchange can exclude user, yes. Or they could just write, yes. That's a very good point. And again, there's a session on attacks. I mean, we're almost out of time, but I still have a lot of things to say. For me, it's not a problem to stay here more, but I don't know. Okay. Yeah. Let's try to get quicker into the attacks, which is the most important thing. Merkle proof of inclusion. So, like, the issue with this, with the model that I described here, is that, let's say Alice is receiving like this data, like this nodes, this information in green. So what Alice can tell is that there is a user with a balance of 50. There's like 2 users, which sum of balance is 25. And so let's say that with this design, there's a lot of information about the user base of the custodian that gets revealed to Alice. And this is something that is bad. Like, we want to avoid that. It's bad from like the user perspective, but most importantly, it's bad from the custodian perspective, because they don't want Alice to basically, I don't know, let's say, track the information of another user. In a real world example, this will not only be it, but it will be like other currencies, like many currencies. So we don't want Alice to basically know the trading behavior of Bob. And of course, in this design, the one based on Merkle proof of inclusion, this is what happens. So there's like data leakage. Let me go back to full. In order to avoid that, we use a ZK proof of inclusion. So we as Summa, so the ZK proof of inclusion is just revealing as public input outputs, the leaf hash and the root hash. So there's no data leaks. Like this data do not get revealed to Alice. And I think it's worth mentioning that there's another point. So there's another way to achieve privacy is through splitting these balances. So I think this is a solution that BitMEX, yes, they do. So they still rely on proof of inclusion, but the, let's say Alice leaf is split across 8 leaves. So there's gonna be one leaf with like 1 ETH, 1 ETH, 1 ETH, some with 2. So Alice will need to, basically Alice will be split across different leaves. And the problem here is that the tree gets bigger. So every user is split in 8. So it gets like 8 levels bigger, I believe. I'm not sure. And also the user will need to verify 8 proofs. So this is bad both from performance and UX. Well, in the ZK proof of inclusion, there's like a leaf hash, a root hash, and just the proof. So the user will need just to verify the proof, check that the public inputs are met, and that's it. So it's similar like to basically like Semaphore, or there are like many ZK privacy applications that rely on a ZK proof of inclusion to hide other user data. And of course, this comes with a trade-off, which is the ZK proof of inclusion. It's more expensive to generate compared to a simple Merkle proof of inclusion. So that's the trade-off there. P, of course, yes. Thank you, Ali, for mentioning. Is the proof of inclusion something similar to Semaphore? I think you said that before I mentioned Semaphore. It's kind of similar. It's well, it's kind of similar. We'll see later why, but it's not the same, honestly. Ali, can we? So, oh yeah, okay. So to be aware of everyone time, let's do Q&A after the presentation. We can stay longer to continue. Well, I mean, I can also just stop here because like right now there's a big session on attacks that starts. So if you guys want, we can stop here for today. I can take other questions if there are, and we can just postpone this this session to, when is that? Thursday, I believe. So there's gonna be one more session, and I will try to be faster in the future. What do you think? Or I can stay longer right now. Up to you.
If anyone has objections, like post in the chat, like, do you want to go over attacks, like, or we stop here?
Maybe I think it's better to start a new session with attacks so that it's like more focus. Today we covered the like basic ground, fundamentals of Summa. The next lecture
Okay.
we can cover the rest, all the attacks. It's more focused.
Sounds good.
Yeah, I think that's a good point also, because like, you know, now like you guys can you know, digest everything about proof of solvency and yeah, think about the attacks, and also maybe figure out some attacks. Maybe we can take this as a sort of a challenge for next next meeting. So if you can I don't know what is like the channel, but if you can try to think about as many attacks as you can about this protocol, then we can discuss them in the next session. Because of course, I mean, there are like many attacks. Like I'm sure there are many attacks, and I will stop sharing. Like there are like some attacks that can be solved on a code level, and there are some attacks that are more inherent to the design of the system. So as Sebastian mentioned before, like the fact that users need to verify proof for the protocol to be sound is a kind of a drawback of the design. So this is an attack that cannot be 100% solved, but this can be mitigated in some way. So if you can write in the group somewhere on Discord the attacks that you can think on, then also we'll start with that on the first day.
Sounds great. We can continue with the questions, I guess.
Okay, perfect. Is there the specification of the protocol? I found only descriptions. You mean Summa protocol or general protocol?
Yes, this protocol.
This protocol. Yeah, I mean the thing that you can see is on Gitbook. So I don't know if you think this is a description but I think this is probably it's not like a formal specification, but this is the best you can get. Is there any relevant tool to detect or analyze possible attack on that mentioned just now? No, not really. I don't think this is something that you can. No, there are not tool available for that. It's like a very, like, fortunately or unfortunately, I think unfortunately, this topic of proof of solvency is not like a super broad in the world. So we are not yet at that phase. Okay. If you give me a second, I want to share with you the paper that I mentioned before. Okay, I don't find it right now, but I will look.
Yeah, I think we can post
and,
it
yeah.
with the recording of the video if you want, Enrico.
Yes, yes.
Do we have more questions? Or if we missed some questions that were asked in the chat?
Okay, perfect. So we are like perfect on time, 11 o'clock. Yeah, cool. Thank you guys for listening, and we can continue. There's a last question. This is off topic. Does having proof of solvency mean there are use cases in which a transparent decentralized solution is not superior? Yeah, this is a very good question. Well, I mean, I'm kind of biased here, but I suggest you to go through this blog post of Vitalik that I will also share with you later. And I think the core thesis there, which is also my personal thesis, is that, you know, right now we are like at the extreme of the spectrum. So we have like a fully decentralized solution and a fully centralized solution with their trade-off. And I think what we can strive for is a solution in the middle. So it's like something that takes the best of both worlds. So you have like the security, like the cryptographic security, that like the exchange is not cheating, they will not like steal money, they will not run away with money, but at the same time you have the advantages of a centralized solution, which are like the low fees, the fast settlement, etc. So we are basically trying to move in this, we're like trying to get into the middle by starting with the centralized exchange and moving it closer to the centralized solution. While I think it would be very difficult to do the opposite. So starting from a decentralized solution and moving it to more close to the middle. But in general, like even like a roll up is kind of similar. So you're trying, if you look at like a Stark X, for example, this is a validity roll up for an exchange, and this is also kind of trying to move the needle towards the middle. It's like a off-chain operation, off-chain transfer, etc., and on-chain settlement. So yeah, we're trying to move stuff, like getting the best of both worlds. Okay, I see people are leaving. I will also leave. And guys, thank you, and see you on Thursday. Bye.
No, Friday. Thank you, Enrico. Talk to you Friday.
Friday, sorry.
Yeah, 10 a.m.
Bye.
UTC. Thank you.
Yes.
Bye-bye.
Bye.
Thank you. Bye-bye.